actually commit our changes first. Okay, so here's the prompt that we'll use. Add vector embeddings and ChromaDB for candidate similarity search. Use Pydantic AI's Embedder class with Google GLA Gemini Embedding 001, 768 dimensions, task type, semantic similarity. Create a wrapper module for ChromaDB that handles storing and querying embeddings, keyed by candidate ID. Store ChromaDB data in data/chroma, so where we also store the SQLite database. This is admittedly quite prescriptive, and that's because I want to make sure to steer it to the right Pydantic API. It originally struggled a little bit with this. It would eventually figure this out. We might have to point it to the documentation page and things like that. But I think this is, since we know what solution we want, being a bit more prescriptive here will be helpful. Okay, then in the synthesis step, after creating candidates, generate an embedding for each one from a combination of the candidate's one-liner and solution overview and store it in ChromaDB. So this is important as well, right? So we don't just want to put like everything in there. That wouldn't work super well. So we want like a nice, concise text that captures the gist of the idea, right? And the one-liner and the solution overview together do a pretty good job at capturing that. So that's what we use. Note that the model returns non-normalized vectors, so you'll need to normalize these before storing them in ChromaDB. So this is important as well. And that's something that's a little bit specific to ChromaDB. pgvector for Postgres actually comes with its own operator that you can use in a SQL query to calculate cosine similarity. And that one automatically takes care of normalization. But in our case, ChromaDB doesn't do that. So we actually need to make sure that the vectors are normalized. So they all have a uniform length of 1, right? That's what that means. And that's an easy pre-processing step here. And then finally, add ChromaDB to dependencies. So let's kick this off. Okay, Claude is done. Let's see what it did. It added a chroma path setting to the settings file. We have a new embeddings module as a wrapper. Okay, so that's what we asked for. Has the right embedding model, semantic similarity task type, normalizes vectors first, and then a function to query similar candidates. Okay, and then in synthesis, after we create candidates, we now generate embeddings from one-liner and solution overview. Cool. Yeah, that sounds right to me. Quick look in here. So this should just be the new ChromaDB dependency. Here as well. Actually, a bunch of transitive dependencies. Settings. That's just the path, analogous to the DB path. Let's look at embeddings. So that's a new file. There's the normalization. Store candidate embeddings. Okay. We'll probably change this method later. We'll actually want to just look at candidates within a certain time period. But that'll be easy to tweak. The principle should stand. Let's look at the step changes. So that's pretty minimal as well. So after we have the candidates, we just call this function to calculate the embeddings using this text. So the candidate's one-liner and solution overview, and then store this. Okay, that looks good to me. We'll run the tests. The tests look good. Let's run this once, even though we're not doing much with it yet, but just to make sure that actually getting the embedding works. Okay, looks like we got an error. So let's scroll up a bit. Okay, so looks like the problem is actually with the embedding model using Google API key. I have a feeling it might not be properly using the Pydantic AI API. Let's paste this into Claude. Okay, so I'm just telling it that I'm getting an error, and to double check it, looking more at the exception, I don't think Pydantic is the issue because it's actually Pydantic that's throwing this error. So we might just need to set another API key here. Although I have a feeling it should just be able to pass this in correctly, since we already have the API key specified in our settings. Okay, it fixed this pretty quickly. The embedder was using the string model name, blah, blah, blah. Now it explicitly constructs a Google embedding model with the Google provider. All right, let's try this again. We'll do resume. Okay, now it finished successfully. So we should see, if we look at our files, data, see there's a new Chroma directory. And then here we have chroma.sqlite3. Chroma actually internally uses SQLite3 for the data storage. So it looks like it correctly created everything that we want.